for this one here, these, because I have a feeling one of these might have showed up on there. So there's two ways to go about these, and unfortunately, because they do have variables x that don't have an actual value, we can't plug them in. There are calculators that can do these here, but they're banned from the ACT. The TI-9 or TI-89 and above can do these because they actually have programs built into them to treat it as a variable, not as a number. But if we do this here, there's two methods to do it. Now, normally I go through both methods, but today we're mainly going to stick with method 2. Because even in the past, I only really show method 1 once, and then we mainly stick with method 2. Yes. So if we look at this here, this is a complex rational expression. And the reason we kind of call it a complex rational expression is because, well, there are fractions inside of fractions. So we call it complex. Now, the first method, if we were going to do it by it, what we would need to do is turn the denominator, which is two terms being added together, into 1. So we would use the methods that we learned yesterday, well, not yesterday, but Tuesday and Wednesday. We would get the denominators to be the same and then add them together. So, okay, I'm actually going to walk this one through. You don't have to copy this down because I'm going to do it again by method 2. So what we would need to do is, well, the numerator is already a single term. So that's fine. We need the denominator to be a single term. So to get them to be the same, well, x plus 4 plus 2 over x. We need the denominators to be the same. So for the 1 over x plus 4, for it to have the same denominator, I need to multiply it by x over x. For the 2 over x, I need to multiply it by x plus 4 over x plus 4. And if we do this here, well, the numerator is still going to stay 5 over x plus 4. Now the denominator, well, the first one is going to be x over x times x plus 4. I'm not going to factor it down. Plus, or multiply it out. The denominator here is going to be x times x plus 4. And the numerator is going to be 2x plus 8. Now, since the denominators are the exact same, we can add the numerators, which would give us x plus 2x is 3x plus 8 over x times x plus 4. So, doing that and getting the denominator to be one fraction, I now have a fraction being divided by a fraction. So what we can look at it, and the way we can look at it now, is that I have 5 over x plus 4 divided by 3x plus 8 over x times x plus 4. At which point, we can change it from division to multiplication. And flip the second. So we'd have x times x plus 4 or over 3 times, or 3x plus 8. Well, so x plus 4 and x plus 4 would cancel. And it would leave us with 5x over 3x plus 8. Questions on any of this here? Let's restart. Let's look at the numerator. 5 over x plus 4. If I were able to multiply the numerator by x plus 4, what would happen? What would happen to, let's get a highlighter, this x plus 4 and this x plus 4 here, if we multiplied it? What would I get? 5 times x plus 4 over? Well, wouldn't these two cancel each other out?
Yes.
Because let me write it out. Exactly, we would have in the numerator 5 times x plus 4 over, so that would simplify too. So if I can multiply the numerator by x plus 4, well, it would cancel out in the denominator, yes? What about, let's get another highlighter out, if I did the same thing with this one down here? It'd just be 1. Okay, well, that works well with those two. But what would I need to do for the 2 over x to get rid of its denominator? So I need to multiply it by x, yes? But that's, I'm going to put it back. Hold on a second. Because we need to multiply the top by x plus 4, and that would cancel out every denominator in the numerator, yes? The denominator, I need to multiply it by x plus 4, and I need to also multiply it by x, yes? And that would remove all the denominators in the denominator, yes? But we're here, and what we're talking about is multiplying just the top and just the bottom, yes? So what could I do? I could actually, well, if I didn't have a highlighter, I had a pen. So on that thought process, maybe I can multiply the numerator by x times and the denominator by x times, because x times x plus 4 over x times x plus 4 is just 1. So it's not changing it, it's just changing how it looks. So if we do this in the numerator, well, this is all going to multiply by every numerator in the numerator. So we have 5x times x plus 4, and we'll simplify here in a second, over x plus 4. Well, as we see here, the x plus 4 and x plus 4 will cancel out. In the denominator, we do have to multiply it with the 2 and with the 1. So with our 1, we'll have x times x plus 4 over x plus 4. Plus, here we'll have 2x times plus 4 over x. So, what simplifies? Here, x plus 4 and, so we get 5x. The denominator, it leaves us with x. Here we have the and, which leaves us with plus 2 times so now we just need to simplify, because the denominator we have x plus 2 times x plus 4. So we still have 5x in the numerator. 2 times x is, 2 times 4 is, over. Is that the same thing we got doing it the other way? So which one's easier, this way or the other one? Because the other way, we had to actually add the two denominators, then rewrite it out as division, change it from division to multiplication and flip. Here, we really just needed to see what's going to make the denominators on top and bottom all going to cancel out. So we saw it's x times x plus 4. Multiply top and bottom by it, which canceled out all the denominators on top and bottom, and simplify. And that's all we have to do. Questions on this here? So let's look at this one here. And I have a feeling we want to do it by method 2, not method 1. So we do have 3 denominators in this complex fraction, yes? One of them is x minus 2, another is x minus 2, and the third one is x. So, out of all of these here, we know that we will need an x for the 3 over x. We'll also need what? For the 6 over x minus 2, yes? Do I need another x minus 2 for the 1 over x minus 2? In each of the denominators, how many times does x minus 2 appear in each one? Once, because in the top it appears. In the bottom, 1 over x minus 2, it only appears 1 time. I will need it twice if one of the denominators is what? X minus 2 times x minus 2. Because if in any of the denominators it appears more than once, then we will need it more than once. But here, even though it does occur in these 2 spots, in each spot it only occurs, so we only need it once. So, when we multiply for the numerator, we'll have 6x times x minus 2 over x minus 2. For the denominator, well, 1 times x minus 2 is just going to be x times x minus 2 over x minus 2 plus 3x times x minus 2 all over x. Questions on this here so far? So let's see what simplifies in each one of these fractions. So at the top we have the x minus 2 and here we have the x minus 2 and lastly we have the x and. So on top we do have 6x, and on bottom we have x plus 3 times x minus 2. On top we still have 6x. We do need to simplify the denominator. So we'll have x plus 3 times x is 3 times negative 2 is well, x plus 3x is 4x minus 6. Exactly, we do have to simplify this. Because if we look in the denominator, do they have a greatest common factor? 2 that I can factor out, which would leave me with 2x minus 3. And on top we have, well, the 6 and the 2 here can simplify, which would leave us what in the numerator? And then the denominator is 2x minus, and that's it. We can't simplify the x's because in the denominator it's 2x minus 3. Those are stuck together. Questions on this here? Let's look at this one here. Now this one here does not have any variables in the denominator. But we do need to get what? 6, 3, 5, and 10 to be the same. So what can we say is the first number that would make 6, 3, 5, and 10 be the same? So we can look at factors of 3, factors of 6, factors of 5, and factors of 10, yes? It will be 30. Because here we have 3, 6, all between 3 and 6, the smallest number is 6, yes? Well, 5, 10, between 5 and 10 it is 10. But let's actually go 12, 18, 24, 30, 36, 42, and we'll stop there. Here, 5, 10, 15, 20, 25, 30, 35, 40. Here, 10, 20, 30, 40, 50, 60, 6, 9, 12, 15, 18, 21, 24, 27. Well, 30 is the first number that does work. Would 60 also work? Yes. But the difference between 30 and 60 is kind of scale of 2. So if we do use 60, that's fine, but that extra factor of 2 would have to be factored out at the end. So it would still work. So here, top and bottom by 30. So if we do this here, the numerator, so 30 times x, because we're multiplying by the numerators of the numerator, we would have 30x over 6 minus 30x over 3. Then in the denominator, again, we're multiplying this 30 by the numerators of the denominator. So we'd have 30 times x for the first one over 5 minus, well, 30 times 7 is, because 3 times 7 is 21. So we just add a 0 because 30 times 7 would be 210 over 10. Now we do need to simplify each one of these here. Well, 30 divided by 6 is 5, and we would have x. Here, 30 divided by 3 is, so minus 10x over 30 divided by 5 is 6x minus 21. So the numerator 5x minus 10x is negative 5x over 6x minus 21. Now there is a greatest common factor in the denominator with the 6x and 21 is 3. Let's go on and factor it out. Times 2x minus 7. Well, will the 3 and 5 simplify at all? No. So that's the answer.
I like that.
But that's all we have to do for these here. Any questions on any of these here? What will we need to multiply the top and bottom of this one by?
2.
Guys, if we look at this here, in the numerator and denominator,
12.
Which ones have a denominator in the numerator and denominator? Would be our 2 over x and 2 over x here. So if I want those to simplify, I need to multiply them by x. Yes? Now we have the 3 and 4 also, don't we?
Yeah, that's awesome.
Do those have a denominator? So 1, but I don't have to worry about them because all I'm trying to do is simplify the fractions that are inside of the fraction. Well, since the 4 and 3 don't have a denominator other than 1, we don't have to worry about them because the only ones we're focused on is the 2 over x and 2 over. So we multiply this x through. Here we're going to have 2x over x minus 4x. In the denominator, we'll have 2x over x plus now here our x and x would cancel. Here the x and x would cancel, leaving us with negative 4x plus 2 in the numerator. I flipped them to the variables first. And in the denominator, we would have 3x plus 2. Do we have a greatest common factor in the numerator? Between 4 and 2. Now, there's 2 ways we can factor this out. Now, one of the ways we can do this is I can actually not just factor out a 2, but a negative 2. And if I factor that out, I'm left with 2x plus, not plus, it would be minus 1. Two x minus 1 over 3x plus 2, because there's not a greatest common factor between 3x and 2, so we can't do anything with the denominator. So this here would be one of the correct answers. Because the other way we can do this is just factor out a 2 I just didn't factor out the negative. So I could factor the negative out or I can leave it in. I prefer, if I was doing these, I normally factor the negative out. I like to try to keep the x variable positive, the one with the biggest exponent, which here would just be x. But both of them are really the same because it doesn't actually do anything. If we did have a negative in the denominator that we could pull out also, then it could make the whole thing positive. Or especially if the denominator was a negative 2x plus 1, then we can leave it in and they would cancel out completely. But here, because nothing's actually going to simplify, it really doesn't matter. Questions on this here? All right. I feel like y'all are getting the hang of this, yes? Let's skip this one.
Whoa. These look like it's hard. People weren't even trying to make it hard, or people weren't
The last one's more of an art project than this one. Nope. There's one more after that, I believe. Yep. Let's do two more. Which two of these do y'all want to look at?
This one or the next one?
No, let's not do this one. This one's like.
Let's do this one. This one's fun. We'll do the x plus minus 1 minus plus 1 minus, yeah.
This one here? Okay. So, looking at all four of these fractions, we know that we'll need to multiply at least two of them by because the x plus 1, let's get the highlighter out, we'll simplify the x plus 1 out of this one here and this one here. The x minus 1 will simplify this fraction and this one. Now, if we multiply these together, because on top here, I'm going to have to grab my own note sheet. Mainly because I made the one there a little too big to be able to still see it and write everything at the same time. We have x minus 1 times x minus 1 times x plus 1 over x plus 1 minus, here we're going to have plus 1 times x minus 1 times x plus 1 over x minus 1. And the denominator, we have x minus 1 times x minus 1 times x plus 1 over x plus 1 plus x plus 1 times x minus 1 times x1 over. So we multiply the numerator of each one of these by x plus 1 times x minus 1. Questions on this here so far? Let me know when y'all are ready for the next part, because it's going to take a little bit to write all that down. Yeah. All right, we ready for the next part? Simplifying. So here, the x plus 1 and cancel. Here, x minus 1. Here, and x minus 1. Which, incidentally enough, in the numerator, on the first one, all I'm left with is x minus 1 times. Well, it would do that. One more time. Well, we have x minus 1 times x minus 1 minus x plus 1 times Yep. Yeah, it does work out that in each spot we get the same thing in both sets of parentheses that's left. So x minus 1, x minus 1, x plus 1, x plus 1. X minus 1, x minus 1, x plus 1, and x plus 1. Now, it would be really nice if it did, but because of the plus in the denominator and the minus on top, they're stuck together. We can't just cross them out. If we did have them be alternating in the top, they had one of each, we could actually use our factoring or our greatest common factor twice, the factoring by grouping, and factor one of them out, have them multiplied, and then simplify that way. But here, we need to actually multiply them out. So the numerator, I had a feeling it would do that. There's some type of gesture that I'm inadvertently doing it to cause it to scroll. Now for x minus 1 times x minus 1, x times x would give us minus 2x or minus x plus 1 if we multiplied it out, which would give us x squared minus 2x plus 1. Yeah. So x squared minus 2x plus 1, because I'll work it out over here, because we would get x squared minus x minus 1 plus 1, which would give us x squared minus 2x plus 1 if we worked it all the way out, which means the x minus 1 times x minus 1 on bottom is going to be x squared minus 2x plus 1. Minus. On top, I'm going to put minus and set of parentheses, because we will have to move that negative through it. Now for the other set, we have x plus 1 times x plus 1. X times x would give us squared plus x plus 1, which is actually x squared plus x plus 1. So the only difference between the two is the fact that the middle term is positive instead of negative. So the numerator, squared plus 2x plus 1. Now we don't have to worry about putting parentheses around it in the denominator, because we are adding the two instead of subtracting. So let's see what we're doing here. So we would have x squared minus x squared. Or here, I'll just go on and write it out. Minus 2x. So the x squared would become negative. The 2x would become, and the 1 would be well, I'm not going to go on and write out the denominator. Let's go on and simplify it. So x squared plus x squared is 2x squared. Negative 2x plus 2x is 0. These cancel out. 1 plus 1 is see what happens in the numerator. X squared minus x squared is, those are gone. Negative 2x minus 2x. 1 minus 1. Cancels out also. Exactly, because the denominator has a common factor of what? 2. 2. Well, we can factor out the 2, which would give us negative 2x over x squared plus and that would be it. I might throw one of these as a bonus. Any questions on this one here? Now the one before it with the y squared and x y in the middle, we would actually just have to multiply the top and bottom by x squared, y squared. Would be all we would need to do. Because in any of the terms in there, x and y, and all the spots are just in there once, so x squared, y squared would work, even for the middle term. Is there one more that y'all want to look at? Because I believe this here actually works out to be x squared plus 1. I've worked this one several times. It's not I just looked at it and knew. If you don't want to just watch this one, I can do this one through. Y'all don't have to write it down. And I will jump a few steps here and there. Like for the x minus 1 times x minus 1 we did on the last one, just jump to the fact that it is x squared minus 2x minus 1 for some of these. Now this here, since we have an x plus 1 and x minus 1 squared in the denominator, we're going to have to multiply the numerator and denominator by x plus 1 squared and x minus 1 squared. So when we do this with the numerator, one of the x minus 1s for the first one will simplify, which will really leave us with x plus 1 cubed times x minus 1. And for the other one, well, this here, 1 minus x, is actually the same as negative x minus 1, because I'll pull the negative out. And actually this negative and negative make a positive. So we actually have plus x minus 1 on top. Plus, here we're going to have x minus 1 cubed times x plus 1, because the denominator realistically is x plus 1. They just have it written flipped. Now the denominator ends up being x minus 1 squared, because the x plus 1 squared will cancel, plus x plus 1 squared. So we get this here. Now the denominator, as we saw already, x minus 1 squared is just x minus 1 times x minus 1, which will actually give us x squared minus 2x plus 1. Plus here is going to be x squared plus 2x plus 1. This here is kind of a cheap shortcut for the cubics. So the leading coefficients for these here are going to be 1, 3, 3, 1. So if I took x plus 1 cubed, it actually works out to be x cubed plus 3x squared plus 3x plus 1. And we'll be multiplying it by x minus 1 plus the x minus 1 cubed. Any of the ones that would occur where x is an odd power, or so it's going to be x cubed. Now the second one is going to be really the negative 1 will be to the first power, as it is b, so we'd actually get minus 3x squared plus 3x minus 1 times x plus 1. And that there is really using a cheat of this. Well, it would scroll. Okay, it's just going to keep doing that. Of this here, where the first term is considered a and the second's b. So a cubed b0, a squared b1, a1b squared, and b cubed. So at the first and third spot, since it's negative, those signs would be negative. Now, the denominator, we can do some simplification. The 2x and 2x would be gone, really, for the first one, because we have 2x squared plus 2 in the denominator. Incidentally, in the numerator, we're going to get x to the fourth plus 3x cubed plus 3x squared plus x cubed plus 3x squared plus 3x plus 1. Sorry. Make sure, because, okay, that's fine. Got a little ahead of myself. Since we have the minus 1, the signs for the second half should all be negative. So it should be negative x cubed, negative 3x squared, negative 3x, negative 1. Plus, for the other one, well, we'll get x to the fourth minus 3x cubed plus 3x squared minus x plus x cubed minus 3x squared plus 3x minus 1. I'm getting those and multiplying them together. Now, as crazy as this looks, x to the fourth plus x to the fourth is going to be 2x to the fourth. X to the third, okay, don't erase. X to the third minus x cubed would be 2. Minus 3x cubed is negative 1. Plus x cubed is 0. So these actually all canceled out. Now we have 3x squared minus 3x squared. Well, okay, those are 0. Over here, 3x squared minus 3x squared, that is 0. X minus 3x is negative 2x. Minus x is negative 3x. Plus 3x is, well, these would cancel. These would cancel. And then we have negative 1 minus 1 is negative 2. Okay. So we had minus 2 over 2x squared plus 2. Well, the numerator does have a greatest common factor of 2, leaving us with x to the fourth minus 1 over, and here we have 2 times x squared plus 1. Well, those would cancel. The numerator actually works out to be x squared minus 1 times x squared plus 1 over x squared plus. Those cancel, leaving us with x squared minus. Yep. But it's still kind of funny that it went from something this big, expanded out to that big, to something that we end up with 2 terms.